Okay, so we're looking at solving logarithmic equations, and there are two different methods to solve them depending on what we have going on inside the problem. So we have here for an example log of x plus 5 plus log of x minus 3 equals log of 3x minus 3. Notice that all of my values are contained inside of the logarithm, so I don't have any random numbers being added or subtracted outside of the logarithms. In this case, we're going to use what we call the one-to-one property. In order to use the one-to-one property, I need a single logarithm on each side of the equal sign. Once I have that, ensuring that they do have the same base, what the one-to-one property says is if the two logarithms are equal to each other, then the stuff that's on the inside is also equal to each other. So we'd start off by, we see on the left-hand side I have two logarithms. So I need to use the properties of logarithms to combine this into a single logarithm. Since these two are being added, then the sum product property of logarithms will tell me that I can then multiply the arguments together to write this back as a single logarithm. So we would have log of x plus 5 times x minus 3 is equal to log of 3x minus 3. And now that one-to-one property kicks in. Since I have two logarithms with the same base that are set equal to each other, the one-to-one property tells me then that the arguments are equal to each other. So I can just set what's inside the parentheses, the arguments, equal to each other, and solve the resulting equation. So we might recognize this as if I FOIL this out or multiply, distribute, I am going to end up with a quadratic. So this is a quadratic. So I'm going to distribute. So I get x squared minus 3x plus 5x minus 15 equals 3x minus 3. And we looked at a couple of different methods, namely factoring and quadratic formula. To use either of those methods to solve the quadratic, I do need it equal to 0. So I'm going to collect like terms. So x squared plus 2x minus 15 equals 3x minus 3. And subtract 3x from both sides. Add 3 to both sides. So I end up with x squared minus x minus 12 is equal to 0. And now you can take it from here on whether you want to factor or you want to use the quadratic formula. You'll end up with the same answers in the end. I do see that this one is factorable. If I multiply negative 4 times 3, I do get negative 12. And if I add negative 4 and 3, I get negative 1. So this factors into x minus 4 and x plus 3. And now to solve that, set each equation equal to 0. And I get x is equal to 4 and x is equal to negative 3. Now for the logarithms, they are only defined for positive numbers. Now how that affects my solution, I can have a negative solution. What I need to check for is when I plug these values back in, do they give me a positive number? Because whatever's inside the parentheses has to end up being positive. So I want to plug my numbers back in and make sure that I do still get something positive. So I'll start with 4. When I plug 4 in, I get 4 plus 5, that's positive 9. 4 minus 3 is positive 1. 4 times 3 is 12, minus 3 gives me 9. So 4, when I plug it in, I get all positive numbers, so I'm going to keep it. It's a good solution. Now I'm going to try negative 3. Negative 3 plus 5 is positive 2, so I'm good. Negative 3 minus 3 is negative 6. So since when I plugged it back in, I got something negative, we call this an extraneous solution. It's extraneous. And so it can't be part of my solution. So I'm not going to use that one. The only solution I have is x is equal to 4. So just be sure that you check your answers in the end. So this is the first method when all I have is logarithms. Sometimes you'll have a random number floating outside. So something like log base 3 of x plus 2 minus log base 3 of x is equal to 2. Notice that in this example, I have a 2 that's outside of the logarithm. It's not attached to a logarithm in any way. So in this method, we can rewrite it as an exponential equation and solve it that way. So in order to do that, I do need a single logarithm on one side and my plane number on the other side. So again, we'll need to use our properties of logarithms to combine these two logarithms into one. Since we have subtraction, then the property of logarithms tells me that I can then combine these by dividing the arguments. So I get log base 3 of x plus 2 over x is equal to 2. And now to write it back in its exponential form, if you recall, we'll do the base of the logarithm raised to the power of what the logarithm is equal to, and that must be equal to the argument. So I get x plus 2 over x equals 3 to the second power, or 3 squared. So x plus 2 over x is equal to 9. Now you might identify this as a rational equation, regardless if you know what that is or not. The way to solve this, it's a fraction. I need to get rid of the fraction. So I'm multiplying by x, so I'll just, dividing by x, so I'll multiply both sides by x. On the left, the x's would cancel out, so I get x plus 2 equals, on the right, 9 times x is 9x. And now I have a linear equation to solve. If I subtract x from both sides, then I end up 2 is equal to 8x, which is the same thing as 8x equals 2. It just feels more natural that way. And now to get x all by itself, I divide both sides by 8. So I get x is equal to 1/4. So the same restriction holds. Oh, you can't see that. The same restriction holds. It doesn't matter what x is equal to, as long as when I plug it back in, I keep a positive number. So I'm going to check. 2 plus a fourth is 2 1/4, so that's positive. If I plug in a fourth is positive, and so here it will stay positive. So I know that x equals 1/4 is a good solution.